This is a gate problem from operational amplifiers that appeared in the 2022 paper for electrical engineering. So here is the problem. The steady-state output Vout of the circuit shown below will, option A, saturate to plus VDD, option B, saturate to negative VEE, option C, become equal to 0.1 volt, and option D becomes equal to negative 0.1 volt. And this is the corresponding circuit. So you find that the capacitor is present in the feedback path, and then here is a voltage source of 0.1 volt connected via resistance R1, and then there is another resistance R2 which goes to ground. So with the capacitor, we already know that the moduli of the capacitive reactance is given by 1 by omega c ohms, and therefore if we are looking for the DC value as well as the steady state operation, the capacitor will simply behave as an open circuit because mod of Xc is equal to 1 by omega c, where omega is equal to 0 radians per second. Because it's at DC, and then we are only concentrating on the steady state operation. We are not bothered about the transient behavior. And so mod of Xc turns out to be 0 ohms, which means that the capacitor can be replaced by an open circuit. So given that this is the circuit we were provided with, under the condition that we are looking for steady state operation subjected to a DC input of 0.1 volt, we can happily replace this capacitor with an open circuit, and therefore this simply becomes an open loop amplifier. Now with an open loop amplifier, once again if we refer back to our basic knowledge of operational amplifiers, this behaves as a comparator. This is an example of an analog comparator, and the output of this comparator can take either of the two values. It can either be the positive saturation voltage or it could be the negative saturation voltage. So from our diagram provided here, the output can either be plus VDD or it could be negative VEE. So we are looking at options of A and B only here, because options C and D are not applicable at all. Now when does these outputs occur? So if the voltage at the positive input terminal, non-inverting input terminal, exceeds the voltage at the negative input terminal, the output voltage will take the value of plus VDD. Whereas if the opposite case happens, that means the voltage at the negative input terminal is more than the voltage at the plus input terminal, then the output voltage will be taking the value of the negative saturation voltage, which is minus VEE. Now in this case we have 0.1 volt which is provided to this negative input terminal via the resistance R1, and then the other one, this end, is connected to ground via resistance R2. So V minus exceeds V plus, and therefore the output voltage will be negative VEE for this question. So the correct option is option number B. Note that this is a question that looks at the steady state behavior, but we can have variations of this question where they might ask about the transient behavior of the circuit. So we will discuss about those questions in our upcoming videos.